go ahead and bounce back over to the Rhino viewport. Now let's take a look at, just to make sure everybody's familiar, some simple navigation issues. The first one being the tabs here in the viewport will allow you to maximize and minimize. Right mouse button will allow you to orbit. Your middle mouse will give you a zoom option, and holding down Shift and right mouse button down will allow you to pan. So let's go ahead and create a point in Rhino. I'm going to use the point command by typing in point and then clicking in the viewport. This point is now constructed in Rhino and can live in Rhino or be brought into Grasshopper in order to be able to use it in the Grasshopper environment. Now, as you are dropping objects into Grasshopper, you may have noticed that they have all kinds of different ways in which they look. Some of them have more on the left inputs, and some of them have more on the right outputs. Let's, for instance, go to the very first tab called Params, the drop-down geometry, and grab the object called point. If you noticed, our canvas updated. We now have a little object in the viewport called point, and we have a little balloon message here that if we mouse over will pop up and say, warning, floating parameter point failed to collect data. That's really just a fancy way of saying, I'm a container and I'm empty. So let's right-click on its name and set one point. If you notice, as we right-click on an object, we have additional properties or parameters that we can have access to. This is consistent with just about every object in Grasshopper. What we're looking for is set one point. And when we do that, you'll notice that the Grasshopper interface disappears, and the command line in Rhino asks us what we would like to reference. I'm going to select the point in Rhino, and you'll see that Grasshopper reappears. You might also notice in Rhino you have a red X communicating to you that this object in Grasshopper is now being rendered in the viewport in Rhino. You can see that with the blue X when it's selected or the red X when it's not selected. So again, the main menu bar at the top of Grasshopper gives you access to some of the functionality that you'd probably be familiar with from most Windows applications. You have the canvas here. At the top, the window title bar, and then a collection of component panels containing all the different types of objects you can use in Grasshopper. Now remember, holding down your left mouse button and dragging an object onto the canvas is really the first step in creating a Grasshopper definition. So Grasshopper Objects. If you notice, this particular object, which is referred to as a parameter object, lives in this first tab here on the left. This object is great if we want to bring a point, for instance, from Rhino and reference it into Grasshopper for use. If we go to the vector menu, you'll notice that there is a submenu called Point. From the submenu, we can grab a different kind of point object. In this case, point XYZ, which will allow us to compose or create a point using the inputs that you would normally associate with a point, X, Y, and Z. When I select this, you'll notice that that point was created by default at the origin. Now, one thing to note is that objects in Grasshopper have a left side, a right side, and a middle. The middle in this case shows you its nickname, PT. And if you notice here at the top, this object has the same nickname, PT. One thing to note is here on the left, the inputs are quite different. Here we have X, Y, and Z. If you notice, when you middle mouse hover over any of the inputs, a little tooltip will pop up giving you some information about what the value is that's defined. In this case, the X component has one locally defined value of 0.0. The Y, we mouse over, 0.0, and the Z, 0.0. Now, if we mouse over the middle of the object, you'll see that we get a little context menu that tells us about what this object does. In this case, the point XYZ creates a point from XYZ coordinates. We mouse over the top of this guy, it says represents a collection of 3D points. Now, the output of these objects, which can be found on the right, we mouse over that, will also give us a context menu, and in this case it says a point coordinate is defined as one value, 0, 0, 0. The top object says one locally defined value, a reference point. So what's really going on here? On the left, you'll see that we have something which is referred to as a parameter object. Gil and I like to think of these as point containers or containers in general. On the right, you can see a component. This is a point component. We like to refer to these as constructors. In this case, a point constructor. And on the left, a point container. So containers, or as David refers to them as params, are really singular entities that reference or contain data. So they store things. A constructor, aka a component, is really a singular entity that facilitates modeling tasks, aka they do things, right? But regardless of which one you're using, you'll notice that all objects, with the exception of just a couple, have on the left something referred to as inputs, on the right output, and in the middle something which is typically the name of the object. This image is courtesy of Andy Payne over at Lift Architects. So you can see the difference between these two objects visually is quite large, but at the same time, the way that you work with the object is going to be quite different. In this case, an object like a point from Rhino brought into Grasshopper will allow us to use this object in Grasshopper. A point created in Grasshopper or constructed in Grasshopper will allow us to create a point by defining it explicitly. So let's take a look at another object that's really nice. Let's go to the params menu and jump over to the input submenu. If you notice in the input submenu, there is at the very top an object called a number slider. Let's drop that down. And if I zoom in, you'll see that this number slider can be interfaced with by dragging with your left mouse button down on this little handle. If I double click on the name of the slider, I have a little pop-up menu that comes up and gives me an option to, at the top, change its name. How about X pos, or X position, or X coordinate? If you notice, under slider accuracy, you can change this to be integers, only even numbers or odd numbers, or in our case, a floating point number with 2 decimal places of precision. You can double click its minimum value, say 0, and its maximum, maybe 12. I'll hit OK. Now, because there were some values already defined in here, and they're referred to as defaults, this point constructor automatically created a point at the origin. Right-clicking on the input Y, you'll see that you have a context menu which allows you to set a number by typing in a number and clicking Commit. In Rhino, we'll have an update. The point is now positioned at 0 in X, 2 in Y, and 0 in Z. But it's not that fun to be able to have to go here and set a number every time you'd like this thing to update. So let's look at how we might be able to use the output of this object, which is the slider, to control where the position of this point is in Rhino. You do that by going to the output of an object, holding down the left mouse button, and dragging out what is referred to as a wire. Now this wire, as it gets closer to an input, will snap. The icon will change where your mouse is, and you can let go to see this point update. Moving the slider grip left and right, you will see that the point now changes in its X position. I'm going to use Edit, Copy, Edit, Paste to bring down another slider and change its name. This time, instead of double-clicking on its name, I'm going to right-click on its name and change it to Y pause and connect that to Y. We'll pause there for a moment so you can give that a shot. And if you'd like, go ahead and replicate that one more time and call it Z pause. All right, now I'm going to jump over to perspective view and take a look at what's happening as I move my slider around. I can see my point is updating in Rhino. My other point is just here. I would have to move it around using the nudge command if I want to see my point move. I'm just using my Alt modifier and the left-right on my keyboard. Or I can use, in this case, my slider to change the position of this point. Now I'm going to copy and paste this down. I'm going to call this Z pause and connect that to Z and go up. And we'll see that now we have a point moving in Z position as well. Now, if you notice, these are 3 separate sliders, but you can, if you'd like, take one slider and share its output by holding down the left mouse button and snapping into another input. We now have a way to be able to change the X and the Y position at once. If I'd like to undo that, I can always hit Control-Z, or I could take the Y position slider and drag it right into Y, replacing the input. Now, for instance, what if we would like to create a line between these 2 objects, in this case, 2 points? Well, lines are curves. So why don't we go to the Curve menu, the Primitive submenu, and pick the line object. This object will create a line between 2 points. If I drag this down, you'll see that A asks for, by mousing over A, a line start point. B will ask for a line end point. Let's say, for instance, you'd like to start at the point you referenced from Rhino. And you'd like to end at the point that you created in Grasshopper. You now have a line in Grasshopper that is parametric. And as you change your sliders, you'll see this line update. We're going to pause here for just a couple minutes so that you can get comfortable with moving your point in Rhino, changing the sliders in Grasshopper, giving names to your sliders, as well as connecting inputs, and lastly, right-clicking on an input to disconnect it. Again, we're going to pause here for just a minute so you can get comfortable with that. All right, great. So hopefully you all had a chance to disconnect an input, connect an input, and replace an input. Obviously, in this case, the same point going to the start and the end will not create a very functional line. Now, one thing to note is that as we were creating our sliders, we attributed names to these sliders to give them a little bit more meaning. Besides just a name, you can also think of the sliders min and max being very related to the context or the use of the slider. For instance, if you could only move 6 units in X, but up to 24 units in Y, the values here might have a very different range, depending upon whatever it is that you're using them for. Now, you might not have the most interesting parametric model you've ever seen. However, this is a fully functioning parametric model at this point. So let's go ahead and take the second really important step in creating a parametric model, which is making sure we know how to save it. Let's go to File, Save Document, and I'm going to save this as my first Grasshopper file. Now, I would encourage you as you're saving your file to probably give this file a little bit more meaning in terms of its naming convention. But for now, I'm just going to call this my first Grasshopper file and save. Remember, you can go to File, Close, and that will bring you back to where we started, which is no document loaded. One nice feature is that you can always go to File, Open, to browse to the file you just had open. Or you can go to File, Recent Files, and pick My First Grasshopper File from the top, and it will reload. When that reloads, you will notice that we have a computed solution once again in Rhino. However, one thing to note, if I were to create a new file in Rhino, so I'm going to say new, I'm not going to save the changes. I'll just pick small objects inches and hit open. You'll see that in Grasshopper, there's no solution computed anymore. Now, if you remember, right when we started, we made note of the .3dm file extension, as well as the .gh file extension. The Grasshopper file has a .gh, and the Rhino file has a .3dm. We had created a point in Rhino. We brought that point into Grasshopper. It's called referencing. And we did it by creating a point container and right-clicking to set one point. That point no longer lives in this file. Therefore, the solution here cannot be solved any longer. In order to get our file back, we would have to create a new point in Rhino, right-click to set one point, and select our point again. Immediately, you'll see that the solution does calculate, and we can see it here verified in the Rhino viewport. The importance of this is very, very big. Now, this is just the point, so it's easy enough to just make a new point and place it back into this container. But for instance, if you were modeling something much more intricate in Rhino and using it in Grasshopper to then further articulate, that Rhino geometry would absolutely need to be saved in order for the Grasshopper file to function later. So let's go ahead and save our Rhino file. Now I'm going to give this Rhino file the same name as my Grasshopper file without the extension. I'll hit save. I'll save in Grasshopper, close my Grasshopper file, and I'll close my Rhino file. I'm going to launch Rhino once again. Just give it a moment to start up. You can see our point right here in Rhino. I'm going to launch Grasshopper by typing in Grasshopper. And from File, Recent Files, I'll grab the file I just had open. Now you can see this file in Grasshopper is now functioning in Rhino. So it's very important to coordinate the two files.